So I think Jason just joined us. So morning, Jason.
Morning, sir.
Oh, okay. So did you get a chance to go through this question?
Sir?
Did you get a chance to go through this question?
Yes, sir. I did get a chance to
Oh,
go through it.
okay. So after doing it, like, did you get a good understanding of like the information, or do you want me to go through it with you?
No, sir, I can just give us the answers, then I can ask. If I went wrong, some I can ask, like, what did I do wrong?
Okay. So I should just get straight into the answers.
Yes, sir.
Okay. So let me just fetch my calculator real quick. So basically, I'm just gonna go through the I'm just gonna go through the calculations very quick, and then we'll see. So the first question, they want the vertical component of the 50 Newton vector. So that's just gonna be, so for the 50 Newton vector, I got negative. Okay, for 2.2.1, I got negative 43.3newtons, 0.30 newtons. And I want the magnitude of the resultant force of the net force. So that's going to be, that's going to be
Sir,
sorry. I'll
sir, could you
just
please explain?
should I explain like how I got the answers and stuff?
Yes, please, sir.
Okay. Okay, so I'm just gonna open this, and let me just try to open something. Nah, I was gonna try to open something blank on the side, but it's fine. So in question two, they say that two forces with the magnitude of 50 newtons and 80 newtons act on a point in the Cartesian plane with the directions below. So basically, we're going to be dealing with these two vectors. And when you look at them, the 80 Newton vector is on the x-axis, so it's horizontal, and the 50 Newton vector is a bit inclined, and it's inclined on a 30-degree angle. So what I always do first, let's just say this is going to be our y-axis, and this side is going to be our x-axis. So firstly, I'm going to establish my positives and negatives. So I'm just going to say this is going to be my positive y, and this is going to be my positive x. So automatically we know that this is going to be our negative side of the x-axis, and this is going to be our negative side on the y-axis. So since we have an angle of 30 degrees here, what I usually suggest when it comes to angles, I suggest that we start on the x-axis and we go to wherever the angle is going to lead us. So usually when we're measuring angles, you're going to start on the positive x-axis and it's going to go a bit like this. So if you want, you can use your 30 degrees, but if you're going to use your 30 degrees, that's not going to give you the sine of the x or y, or of the x or y component. But if you use this angle right here, which is going to be 180 degrees minus 30 degrees, this angle will also give you the sine of the x and y components. So for example, right now, you'll see when we're gonna find 2.2.1, we're gonna say that the cos of 150 degrees, oh yeah, sorry, for 2.2.1, they want the vertical component. Sorry, I think I found the horizontal component instead during that time when I use my calculator. So since it's the vertical component, we're gonna change this into sine. The sine of 150 degrees is gonna be equal to, you can just say force y, or you can just say force 50 Newton y, but I usually just write force y divided by 50. Therefore, we're gonna end up with our vertical component being 50 sine 150 . So do you guys understand so far? Sorry. Oh. So our answer is gonna be force of y is gonna be 50 sine 150, then that's gonna be 25 newtons. So when you guys were doing your calculations, did you get this answer for your first one?
So I got 25. That's why I asked Sir to explain.
Oh, okay. Yeah, sorry about that part because I think I did the horizontal portion instead of the vertical one.
Yes, sir. I saw.
Yeah. So we're gonna go to the next one where they want the magnitude of the resultant force. So in order to find the magnitude of the resultant force, we're gonna have to find our total, our resultant force on the vertical and our resultant force on the horizontal. So from the 18 Newton vector, we can see that it's on the horizontal. So when you see that it's on the horizontal, you know that mathematically it does not have a vertical component. So the vertical component is gonna be zero. It's gonna be 0 newtons because the sign of 0 is gonna be 0. So when it's on the vertical, the angle is 0. Sorry, when it's on the horizontal, the angle is gonna be 0, and the sign of 0 gives you 0. So it does not have a vertical component. It only has a horizontal component. So what we need to do now is find the horizontal component of the 50 Newton vector. And to do that, we're just gonna go in and say cos 150 degrees is gonna give you fx by 50. And then I think I got the answer last time. It was somewhere around like 43 point 150. It was 43.30 newtons. So Kyle, when you were calculating, did you use this angle or did you use this angle? Did you
So
use
I used the 30 degrees.
Okay. So you can use the 30 degrees if you're confident about your directions. But if you're not confident about your direction, you can use you can use 150 degrees, or you can just use the angle from directly from the horizontal line to wherever that angle is. Because right now, if you use 150, you're gonna get this negative automatically. But if you use the 30 degrees, you're not gonna get this negative sign. So if you're confident about your direction, you're like, okay, you're like, you know that this is to the left, is to the left, which means it's gonna be negative, and this is upward, which means it's gonna be positive. So I suggest that you can use the 30 if you're confident about your directions. If you're not confident with your directions, you can use this angle. It's much better. It's much better if you don't know the sign of the vector that you're gonna get. I hope you understand that part.
Yes, sir.
Okay. So now since we have our x component of the 50 Newton vector, we're gonna have to calculate the resultant x component and the resultant y component. So we're gonna say f resultant x, let's just say that's gonna give you negative 43.0. So from this, we know that our resultant on the horizontal is 36.70 newtons. And we know that the 80 Newton vector does not have a y component. So our resultant on the y-axis is going to be 25 newtons. So now we're going to find our resultant vector. We're going to find the magnitude of our resultant vector. So we're going to have use the Pythagoras theorem in order to find the magnitude. So we're going to have r squared is equal to x squared plus y squared just quickly calculate the answer. So when you guys were calculating, was this the answer you got for 2.2.2?
Yes, sir.
Okay, so when it comes to finding the direction, I'm pretty sure like you guys already know that part. So we're gonna say the tangent of whatever angle we're gonna find, that's gonna be y over x. Over 30. So when you guys were calculating, what answer did you get for your theta?
So I got 34,26.
Okay, so I guess like it wasn't really that much of a hard question. So this is basically what I asked from you. So did you try the other one? Because I think that one was a bit more difficult than this one. So did you guys try? I think let me open it up for you. I think yeah, it's this one. Are you guys able to try this one?
I did not do it.
Okay. So Jason, did you try it? Okay, so we're just gonna go through, we're just gonna read through the statement, and then you'll tell me what you understand from the statement, and then we'll take it from there. So they say block A is at rest on a horizontal rough surface. So every time you hear that the surface is rough, it should always click in your head that there's gonna be friction involved when you hear a rough surface. And they say it is used to anchor. It is used as an anchor to hold block B, which has a mass of 56 kilograms in the air at a certain height above the ground. The two blocks are connected with rope R, which makes an angle of 35 degrees with the vertical, and block B is suspended from the ceiling with cable C as per the diagram below. So just from like the statement we just read, what do you think we have to change about uh, which vectors do you think we're gonna deal with in this particular question? Like you can just say, let's say block block A and block B are connected. So block A and block B are connected. Let's just say there's gonna be a vector from block A to block B, and you 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 give me the direction, whether it's gonna be to the left, to the right, upward or downward. So do you think you can find that here?
So
Um okay. Can you give like a free body diagram of A and B, just from your imagination, instead of like having to
first,
down and stuff?
so would it be like with A to B would be like almost like the hypotenuse,
Okay.
and then B, and then that little dotted line up there, that will be like that will be the Y component, the vertical,
Yeah.
and then from there is like gonna be like an imaginary X component.
Okay. Yeah, I think that's a very nice way of saying it. So actually, let me just draw a few vectors here to help you out, because what you said is correct. So we're just gonna draw like this is gonna be our x-axis. So we're gonna have a vector connecting B and A, which is most likely gonna be something like this, because A is used to anchor B. And then we're gonna have another one connecting B to the ceiling. Sorry, let me just let me, and since B is just hanging there and they say it's above the ground, we're gonna say we automatically know, or let's say if if anything is on the ground or above the ground but it's on earth, there's always going to be that force of gravity affecting it, right? And then since B is hanging, the force of gravity will affect it. So we're gonna have another another vector pointing downwards on B. So basically, this is like the free body diagram of B. You understand that part? Okay.
Yes, sir.
Okay. So then they say that block A experiences a frictional force of 200 newtons, and the system is stationary, so the system is not moving. So this vector here is gonna have a force of 200 newtons. And then now, since we have a force and we have a mass, what do you think? What do you think we're gonna have to do in order to convert this mass into a force when we know that there's gravity acting on it? Do do you guys know the formula for gravitational force?
Sir,
Do you know the
EP
formula
equals
for gravity?
mgh.
Oh, okay. So that's what we're gonna have to use it somewhere on in the next questions. So wait, let's say they say define resultant vector. They want the magnitude of the resultant force acting on block B. They want you to draw a free body diagram, which I already did for you. They want you to determine the horizontal component of the rope on R, sorry, of the rope. They want you to calculate the vertical component of the cable, and they want you to calculate the angle between the cable and the ceiling. Okay, so we're gonna do you guys want me to like define the stuff for you, or do you want us to get like straight into the mathematics? Because like,
so can you first do it on our own?
can I first define it?
Or can we do it on our own, sir?
Oh, okay, then no problem. So I don't know because I'm gonna have another class with the grade 10s after this. So how about you do it on your own and then you'll send me pictures on WhatsApp. Is that fine?
So what number is it again?
Sorry?
What number must we calculate for now?
Basically you can try to calculate everything, and if you have a problem you can communicate with me via WhatsApp.
Okay. So is the lesson ending now?
It's fine. I don't have to keep you guys here for too long because I want you guys to be able to solve the questions, so you can do them on your own. We can and then communicate with me on WhatsApp, and then we'll see if you get better using this method. If you don't, then I guess I'll have to find another way to like teach you guys. But yeah,
Yes, sir.
I think we can end it now. If you don't have any
Okay,
questions.
yes, sir. No, sir.
Oh, okay. So Jason, are you fine?
Yes, sir.
Okay, thank you. So I'll see you guys on Thursday, right?
Alright, so have a good day.
Okay, have a good
Yes,
day.
sir.
Bye.